Hello, my name is Jason Close. I realize that I'm the last speaker here this morning, and I know I'm standing between you and lunch, so I'll try and keep things brief. But if you do have questions about what we have to offer and what we're doing with AWS in the cloud, we do have some folks from CMG downstairs who would be happy to help answer your questions about how we've been able to migrate simulation to the cloud. So Arno this morning talked about who's really going to be the innovators in cloud, and what I'd like to tell you today is CMG is a cloud-native startup ready to help you in the cloud. Well, actually, that's not true. CMG, if you know who CMG is, we've been around for about 40 years in the software solutions industry. We provide dynamic reservoir and production technologies, specifically software, to the oil and gas industry, really focused around solving difficult and challenging problems, so things like unconventional modeling, hydraulic fracturing, thermal and EOR type processes. And as part of our business, we do have specialized consulting services and training and things of the such. So one of the things that I think sets CMG apart and what has helped us with our migration to the cloud is our deep bench of intellectual capital. And I think this is something that sets us a bit apart in the industry. Is if you look at this pie chart, over half of CMG's staff is deployed in R&D, so research and development. So that's providing new technology and applying our existing technology. And a large portion of that is how do we help enable our customers in the cloud. So that's more than 25% of our year-over-year revenue. Additionally to that, another quarter of the group is this thing called CST, and that's our consulting and training and support group. And they're there to help our customers move to that space. And only about a quarter of our staff is in what I call the overhead department, and that's where, of course, I sit. If you're familiar with CMG products, you may see some icons here that you recognize. If not, what I'd like to be able to show you is that our existing on-prem products, we've been able to seamlessly migrate to the cloud to help improve reservoir simulation performance. So in the center there, what you see is our reservoir simulators or the compute engines. They're named IMEX, GEM, and STARS. IMEX is sort of our lowest fidelity reservoir simulator for doing black oil or conventional type reservoirs. GEM is our medium or high fidelity model for doing compositional and unconventional type work, EOR, sequestration. STARS is our very high fidelity model, which we do for doing more mechanistic modeling of things like chemical EOR and thermal processes. So what we've been able to do is take these existing, I'll call them legacy for the sake of argument, compute and move those into the HPC environment in AWS. We have what we call our supporting cast, which is Builder, Results, and WinProp. Those are our existing graphical interfaces, which we've also provided to our customers within cloud. So obviously, kind of self-explanatory. Builders where you would build your surrogate model for the subsurface. Results is where you would actually visualize those results. Bracketing, these are our two newest products. So CoFlow, and CoFlow's been designed from its inception to be cloud-enabled. And it's an integrated reservoir and production system modeling platform, which is a bit of a mouthful. But the idea is that reservoir engineers, production engineers, and facilities engineers can work in the same environment at multiple fidelities, multiple users at the same time to help solve some of the most difficult problems. So some of the problems that we solve today, as well as integrated problems, all within one data source. All of these engines, as well as CoFlow, are powered by what we call CMOS AI. And CMOS is our workflow tool where we do things like model conditioning, so history matching, optimization, so trying to improve field forecasts, as well as things like sensitivity analysis and uncertainty assessment. So CMOS, interestingly, we used to just call it CMOS because it's been around for a while, and we tried to obfuscate the fact that we were doing things like machine learning and doing neural network modeling and proxy-based decision making. But now, as industry has become more prepared for that, we've been able to kind of show our customers what the ability of that is. And really, from a cloud perspective, CMOS enables our customers in a much different way. So what we used to do as engineers is a sequential work. So run one model after the other and condition it, and then run one optimization versus the other and condition it. We can now automate that process, and we can do what used to be sequential work in parallel. So where an engineer might take 6 months to do a project, we can then parallelize that work and do it in a matter of weeks. And we can also get better solutions and non-unique solutions that we can use for our uncertainty assessment. So what do we do for our customers? Really, the bottom line is CMG software suite helps oil and gas companies to generate better returns. Well, that's kind of oblique and doesn't really explain a lot. What we're trying to do is help our customers to optimize E&P investments by improving recovery. And really, to do those experiments on a synthetic or surrogate model is relatively a small investment, but can have a huge impact versus doing it in the field. So just a really basic example you can see here on the left side of the slide is an optimization for hydraulic fracture scenarios. We have the original design, which the customer had optimized through trial and error in the field. And we're just looking at fracture spacing versus well spacing versus MPV on the Z-axis, or Z-axis, I should say. I'm in the US today, so the Z-axis. And what you can see is that we're able to improve MPV on a per acre basis almost threefold by looking at the synthetic data and trying to understand what's best. Of course, it's not just do the most possible, because you can see there's a pretty severe cliff if we go beyond that, but we're able to do that, and then we're able to also look at the uncertainty around that. As we migrate to cloud, the solution gets a little bit broader in that we're not just about improving recovery, but there's multiple stakeholders. So the stakeholders that at CMG we normally think about are the reservoir engineers or the businesses themselves, but there's other stakeholders involved in that solution. So when we're looking at maximizing, obviously, production recovery factor, there's some other key things that we can start looking at as we enable our customers in the cloud, specifically employee efficiency and resource utilization, which have a significant impact on revenue and profit as well. The flip side to that, and we've heard about working in a constrained environment, the reality is most reservoir engineers are working in a constrained environment with on-prem compute as well. And so when they look at their project, usually they're working on maximizing a single solution and not really looking at the search space of all the uncertainty. But really one of the huge value opportunities with moving to cloud is being able to minimize risk. So look at alternative solutions. So looking at things like geologic uncertainty, operational and economics uncertainty, and price volatility. So usually in the time to decision, we don't have the ability to look at some of these other assets, but when we actually scale into the cloud and we can have variable workloads, we have the opportunity to do that. Beyond maximizing return on investment, and that's sort of part of the problem, we have a more logistics-based problem in that what reservoir engineering team is looking at doing on a different time scales require different resourcing. So within a business unit, we may be looking at short, medium, and long-term asset development over the course of a year, and we may have multiple units doing different pieces of that process all at the same time. So in the short term, we're looking at building small models that run really quickly, but we want to run lots of those to look at optimizing things like wells, so rates, drawdown, injection, workover, be able to build a proxy model and get quick solutions. So that we require a lot of small-scale hardware and architecture and software to handle those types of situations. And that you'll see that used on a daily basis. On the medium term, we're looking more at the optimizing field operations. So am I going to drill infill wells or look at child well interaction with parent well, pressure maintenance, completion, field performance, those types of things. So here we're going to be building much higher fidelity models. The time to decision is longer, so we're looking at maybe 2 to 3 months potentially to make a decision. But we're running bigger models, so we need maybe fewer total compute nodes, but we need better compute nodes, so ones with more memory and faster compute. The other piece of that puzzle is the long term. And what we find is that when we're looking at portfolio optimization and long-term planning, everyone does it at the same time. So they're doing reserve season, and then there's budget season. So we've got maybe core scale modeling to look at development strategy and lifestyle planning, and the entire organization is trying to manage as much compute as possible in the shortest period of time. Or they may be looking at end-of-life EOR-type strategy, so they're going to run really large-scale models that have long run times, but at a very fine scale, which require large amounts of memory and high amounts of compute. So the challenge we have is how do I do this in an on-prem situation and provide the team the resources they have, but do it effectively? And the answer really has been that we haven't been able to do that. So just to repeat on that specific point is there's some current challenges, right? So variable workloads. In budget season, everyone wants to do reservoir simulation. In July, no one wants to do reservoir simulation. So how do I build a compute scenario to handle both? And that's not really possible. Different model fidelities. So depending on what type of problem I'm trying to solve, I'm going to need a different type of compute. I may want 10 really small nodes. I may want 10 really big nodes all stitched together to run a distributed parallel computing job. Growing simulation needs. As we get into more and more difficult reservoirs, as we start to focus more on uncertainty and looking at that through things like machine learning, we see that people's simulation needs are growing. In an on-prem scenario, I have to add compute. I have to add software to do that. And that can be challenging to do in an organic way. Really, all this comes down to we have a limited on-premises resource. And building one to meet any of those needs really is probably outside the scope that we want to look at. The other challenge is that we have an aging on-premise resource. So the minute we buy it, it's already out of date. And as we get to 3 or 4 years into production usage, we start to see it become less and less reliable, and that can impact the business's ability to perform. But at the end of the day, it's really about capital efficiency and trying to resolve the capital equation. So in working with AWS, CMG feels that through our SaaS solution, we'd be able to solve most of these problems. So you've heard instantly scalable and flexible today. But from a reservoir engineering perspective, what that means is when I get to reserve season and I need to run thousands of reservoir simulation runs over the course of a couple weeks, I can do that. No queuing, right? This is an interesting one, is that if you've worked in a reservoir simulation environment, usually there's a job queue of anywhere from 10 to hundreds of simulation jobs. If I'm trying to do something innovative and I want to try something new, am I likely to go and try something new if I've got to wait for 100 jobs to finish, knowing that I probably have a couple of weeks at best to come up with a solution? Not likely. So the challenge in an environment where we're always competing for resources is it actually stifles innovation and the ability to look at new ways of solving and tackling the problems that we face today. Instant access. So we're sitting in a meeting room, we decide we have a big problem, I need to go and try and tackle that. In an on-prem solution, how do I do that? Well, you go to all the other reservoir engineers and ask them to kill their jobs, right? Stop doing what they're doing. That's difficult to do. When we have new challenges, we can instantly access our AWS solution. It's the latest hardware and it's simulation optimized. So looking at that limited and aging on-premise resource. We work day in and day out with AWS to search their hardware space within the different environments. And we work together to make sure that it's simulation optimized so that our customers get the best performance experience. Interestingly, around that, what we're finding is when we were trying to do some benchmarks of what we had locally versus what we had in cloud, we weren't able to actually even compete with what we saw on cloud because AWS actually is able to get better hardware than what's commercially available. So our customers are able to leverage that through this solution. And finally, we have pay-as-you-go and subscription programs. So if we're looking at trying out a new workflow, we can do that simply with very low level of commitment. And if we're looking at moving away from capital expenditure, we can look at subscription programs. So I'm not a software architect and I'm not in IT, but for those of you that are, here is a diagram of what our product does. If you are in like sort of the business side or the reservoir engineering side, what you need to know is nothing from this, is that we're going to do all this stuff in the background to make the software work like it natively would work on your desktop. I am going to try and stumble my way through this for those of you who are more interested, so please be patient with me. So initially what we have is we do allow the users in this environment to still use the graphical interfaces. Sorry, I must be getting hungry as well. In their local environment. So if that's something that our customers want to do, they still want to touch and feel the software in a more traditional way, we do offer the builder results and CMOS applications locally. When the user is ready to launch jobs or move data to the cloud, we do that through our access management portal, so we encrypt everything and we move it up there. And it's nice to see that people are less and less concerned with security, because what we find is that the security that we're providing and that AWS is providing is much better than what we actually see when we evaluate what our customers generally have on premise. So we move the data to S3 storage, at which point, if I'm not concerned about having on-prem visualization, I do have the ability to have visualization in the cloud, and I will show you kind of how that works a little bit in a second, and so I can access my instances anywhere in the world to do my visualization as well. But traditionally, once our data has been launched to the cloud, we're going to be using some of the AWS-specific technology to then make the process as seamless as possible. So once the data has been moved into S3 storage, we submit a job through the Lambda and SNS management. Through the Dynamo database, we've got everything stored in the company profile, so I can look at kind of what my jobs are doing on my phone or wherever I go. I just log in and it follows me. Then we're using batch for job scheduling and for EC2 scaling. So we've talked about elasticity and scaling. So at this point, what we do is we then move into those instances. So we're going to spin up an instance. In this case, if I'm running a small or medium-sized job, I'm going to run that on a single instance. The software is still parallelized and using everything that's available on an instance. And we're going to package everything within a Docker instance. I don't understand how the magic of Docker works. That's not my forte, but what I do know is that by using Docker, we're able to see about a 10% improvement in performance over what we would see in a traditional environment. And so we're able to pass that performance on to our customers at no additional charge, which is just a general win. The flip side of that is if I have a really big job and I want to distribute that across a lot of nodes, we can do that automatically as well. So we have MPI job placement groups, and through Docker as well, we can spread those jobs out across many, many nodes. We were working actually very recently over the last few weeks with AWS on some of these cases, and we took a job that was taking one simulation job taking 56 hours, not very practical, not likely something you're going to do a lot of. Using the new EFA, so the Elastic Fabric adapter, as well as the latest and greatest C5 nodes, we were able to run this job in about 2 hours. So I've gone from maybe not doing it ever to being able to run many, many simulations and do optimizations on full field scale. OK, at this point, I'm going to switch over to the demo. And what I've loaded here is our results product. As you can see, I've got my laptop here. I'm actually connected to, I've just hotspotted my phone, so I'm not using a fancy internet connection or anything like that. And you can see these are real-life reservoirs that you would normally see out in the field. The objective here is really to just show you that we can easily manage large amounts and difficult to render data across very poor internet connections and make it very seamless. This is just an application portal, so I've got my regular desktop behind me that I can use as well. So here I'm running CMOST on my local desktop, and what I can do here is that once I'm ready to run my forecast case, if I've logged on, which I have, I can just set how many jobs I want to run, and then just hit the play button. And what it's going to do is check all my input, make sure it's ready to go, and it's just going to go and launch all those jobs to the cloud. So it's going to just start spinning up nodes, running simulation, doing the decision making and the optimization, and then giving back my forecasts. Here we go. I've lost internet. I've regained. I've lost internet. I've regained internet. So maybe not the best internet connection. So if I want to look at what I'm running and where I'm running, I'll just excuse sort of the mess up here. This is my active workspace. So I just launched a bunch of jobs. I'm running a bunch of reservoir simulation. If I wanted to run a really big distributed MEMI job, I could submit a new data set here. I'll just go find one. What it's going to do is load up that data set. I can then pick where I want to run it. What software I want to use, so I'm going to run distributed compute software. I know that SAGD is not a big deal here. This happens to be a SAGD data set that's got about 100 million grid blocks. It's a full asset. I choose the type of nodes I want to run, so I might want to run those on mega, so big nodes. Again, I can use whichever software I would like. If you really feel adventurous, you can run the beta software, which I'll do. And then I just pick the number of new nodes and I hit OK. So if you've ever run distributed computing or worked with distributed computing in the past in a general environment, this is not trivial to do. What ends up happening is if I want to run a really big reservoir simulation job, I call up my IT group and say I want to do it. I might be told, no, you can't do it. Too many other people are running right now. If I am told I can do it, they're going to go and tell all the other res engineers to stop what they're doing, which is going to make me really unpopular. Then what they're going to have to do is make sure that all the hardware is the same, that it has all the right interconnects. They're going to have to reconfigure it, and then it's going to be ready to run. So 3 days have passed, and now I can go and do my run. How valuable is that as a customer? Not really that applicable. But here all I have to do is click OK, and we're going to do all that in the background for you. Spin up all the nodes, run it, and pack it all down when we're done. So pretty incredible what we're able to now accomplish through cloud. We can run full field, 100 million grid block cases if we want. I can run my single well forecasting model that I'm running in CMOS, and I can run 20 or 100 jobs at once, and I can finish that whole workflow in the matter of minutes versus hours or days. So just in conclusion, I'm going to try and give you a little bit of time back here for lunch. If we just go back to the PowerPoint for that last slide. What I hope you can take away, and hope we can have conversations about this later today, is about how CMG's cloud solution and how working with AWS, we've been able to provide some value to our end customers. So one, we can improve project delivery with instant scalability and flexible solutions. We're able to do things that we didn't think possible even a couple years ago, and we're able to do them quickly and efficiently. We're going to get access to the latest CMG software and the industry best hardware. I'm not going to beat around the bush here. The software is a lot more expensive than the hardware, so making sure you run on the best hardware possible is actually going to be the most cost-effective solution. My sales guys over there are kind of cringing as I say something like that, but that's the truth, right? The software is expensive. The hardware relatively is not, so you want to run on the best you can. It's secure. It's accessible anywhere in the world 24/7. A hotspot on my phone. I launched some jobs just now. If you're a Reservoir engineer, you can go and do this when you're on the beach. You can leave work early and do it from home, and your boss is going to think you're doing something. I'm not endorsing that. I'm just saying you could if you wanted to. And finally, through improved usage efficiency and flexible pay-per-use options to access hardware and software, it really gives us an opportunity to try new things and look at ways of innovating. I'd like to thank you for your attention. I really appreciate it, especially